Hello student, good morning. I am Dr. K.SINHA, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing chemical thermodynamics. Actually I am reviewing the chapter and many terms I have discussed. As for example, I have discussed a spontaneous process, entropy, units of entropy, entropy of fusion, entropy of vaporization, Gibbs free energy, change in Gibbs free energy. All these terms I have discussed. I have also discussed Hess law, heat of sublimation, heat of fusion, heat of solution, heat of hydration, heat of neutralization, all the things, even the caloric value also I have discussed. Now I will discuss another terms. Now I am going to discuss when sign of free energy. What does it mean? If delta G means change in free energy, if it is negative, if delta G value is negative, it means the process is spontaneous. If delta G value is negative, it means the process is spontaneous, means reaction is spontaneous, means reaction will take place without any problem by own. And if delta G is positive, the process is non-spontaneous, means you have to do, if reaction will not take place simply, you have to do, you have to apply some, you can say heat, some condition you have to apply to start the reaction and to continue the reaction. Then if delta G value is negative, then reaction is spontaneous, means the process is spontaneous. If delta G is positive, the process is non-spontaneous. And if delta G value is 0, it means process is in equilibrium. This is the condition of equilibrium. At equilibrium position, change in delta G, this change in delta G, change in G or delta G, you can tell, delta G or change in G, free energy. G means free energy. Then if change in free energy is 0, it means the reaction is in equilibrium, that is the process is in equilibrium. Now another term, exergonic and endogenic reaction. Now I am going to discuss exergonic, EXOER, exergonic, GONIC, exergonic, and endogenic, ENDOER, endogenic, GONIC. These terms are very, very important. Exergonic and endo. Just remember exo and endo. Then exergonic and endogenic reaction. Now I am telling you what is this reaction. A reaction which is accompanied by decrease of free energy. Decrease of free energy means minus. A reaction which is accompanied by decrease in free energy means delta G value if it is negative. A reaction which is accompanied by decrease in free energy, that is for which delta G is negative, is called exergonic reaction, just like exothermic, same meaning. Then if delta G is negative, then it is called exergonic reaction. Thus all spontaneous process are exergonic reaction. exorgonic reaction. Similarly, reactions which are accompanied by increase of free energy, that is a positive, delta G positive, then these reactions are called endogenic reaction. Thus, all non-spontaneous processes are endogenic reaction, because now you have to apply heat or some condition you have to put. But in exogenic, you have to not do anything, just in a you can tell natural way, just by mixing two things, reaction will start. But in this endogenic, that only by mixing reaction will not take place. You have to heat or you have to apply some condition of pressure. Then now I discussed exogenic or endogenic reactions. Now I am going to discuss effect of temperature on spontaneity. Effect of temperature on spontaneity. For an exothermic reaction, remember exogenic and exothermic, same meaning. Okay, same meaning. For an exothermic reaction, delta H is negative. If delta S, change in entropy I am talking about. Now, if delta S is negative and T into delta S is greater than delta H. Actually, this you have to understand very clearly, and concept is very, very important. Again, I am telling you, for an exothermic reaction, delta H is negative, means heat will evolve. Now listen, if delta S, change in entropy, H means enthalpy, delta H means change in enthalpy, but now I am talking about delta S, change in entropy. If delta S is negative and T into delta S, means if you will multiply the temperature with delta S, multiplication of both T into delta S, if it is greater than delta H, if delta S is negative and T into delta S is greater than delta H, you remember, delta H is negative, that you know, for exothermic reaction, negative. Now I am telling you, if delta S is negative and T into delta S value is greater than delta H, then what will happen? Delta G is equal to delta H minus T into delta S will be positive. Again I am telling you, this relation delta G is equal to delta H minus T into delta S, that you have to consider here, this relation delta G is equal to delta H minus T into delta S. Then now delta H is negative, correct? For an exothermic reaction, delta H is negative. Okay, you are putting the value, then usually you can understand. Delta G is equal to delta H minus T into delta S. This reaction is called actually Gibbs-Helmholtz equation. Gibbs-Helmholtz equation. This relation is very, very important. Now you are putting the value. In a exothermic reaction, for exothermic reaction, delta H is negative, correct? Then in this relation, delta H value is negative, minus T into delta S. T into delta S. Then delta S if delta S is negative and before delta S minus is there, then minus minus plus, because temperature is no negative, no positive, then T into delta S, finally it will be positive, minus T into delta S. Then delta S is negative, then minus T into delta S, then minus minus plus, and delta H is negative. You remember, delta H is negative. Now just to understand that for an exothermic reaction, delta H is negative. If delta S entropy is negative and T into delta S is greater than delta H, T into delta S, it means that will be this term minus T into delta S, finally it will become plus. It will become plus. T into delta S will become plus. And then what will happen? Delta H is negative. Then if T into delta S value is greater than delta H, then it will be positive. Finally delta G value will be positive. Delta G will be positive if delta S is negative. Correct? Because minus is there before T into delta S, minus there, then minus plus, and this value is more than delta H, and delta H is negative. It means finally delta G value will be positive and the process will be non-spontaneous, because condition I told you, if delta G value is positive, it means reaction or process will be non-spontaneous. This question is asked in every examination. Now, if T is made, if temperature, T means temperature, if T is made so low that T into delta S is less than delta H. Now, if you want to decrease the value, then temperature has meaning. If temperature is low, then what will happen? That T into delta S value will be low. If T, because your multiplication is there and T value is less, becoming less and less, then finally this plus delta H value will be less and delta H will be minus delta H will be more. Means delta G will be finally negative, because now plus T into delta H, that value is becoming less because temperature is low. Then minus delta H is now more, and finally delta G will be negative. Correct? Then this delta G will be negative, means delta G will become negative and the process will become spontaneous. Then I told you, if delta G value is negative, then reaction will be spontaneous. Then when reaction will be negative and reaction will be these things spontaneous and non-spontaneous, then this is the main criteria. Correct? Then you have to see the value of delta H and delta S, and also you have to consider temperature. Temperature is low or high. Correct? Because temperature is low, then that will be more positive. T into delta S value will be more positive. Then it will be what? It will be non-spontaneous. If temperature is less, then it will be spontaneous, because finally delta G will be negative. Then these things I have discussed. Hence an exothermic process, hence an exothermic process which may be non-spontaneous at high temperature may become spontaneous at low temperature. Just remember, I have already explained, okay, that if a process or reaction is non-spontaneous at high temperature. Then it may become spontaneous at low temperature. This is the condition. You see the role of temperature. At high temperature it will be non-spontaneous. At low temperature it will be spontaneous. Similarly, an endothermic reaction which may be non-spontaneous, endothermic, non-spontaneous at low temperature may become spontaneous at high temperature. Means for endothermic, just all things will be reversed. All things will be reversed in case of endothermic. I have discussed in details for exothermic. Reverse case will be for endothermic reaction. Now next things I am going to discuss, that is the standard free energy change. How it is related to equilibrium constant. Equilibrium constant is K. How both are related? Then there is a relation, that is also very important relation. If you want to, actually this type of relation is used in solving the numericals. Then what is the relation? Then standard delta G subscript is 0, power 0. That is a symbol to represent a standard. If G power 0 means a standard, subscript is 0. Then delta G subscript 0 means a standard delta G change in free energy is equal to minus 2.303 log K. Here K is equilibrium constant. Then this is the main relation. Very, very important relation. That is the standard delta G. Standard delta G is equal to minus 2.303 log K. Now come to the second law of thermodynamics. Second law of thermodynamics. What is this law? Then second law of thermodynamics states that all spontaneous process or naturally occurring process or reaction are thermodynamically irreversible. Not reversible, irreversible means it will not come back. Okay, so just listen first point of second law of thermodynamics. What does it tell? All spontaneous processes, that is also you can tell spontaneous means natural process. Naturally occurring process is also example of a spontaneous process. Then all spontaneous process or naturally occurring processes are thermodynamically irreversible, or the complete conversion of heat. So this is the second point you can understand. First point I told you that all spontaneous processes are thermodynamically irreversible. Correct? This is the first point of second law of thermodynamics. Other, the complete we can tell, not composite, complete. The complete conversion of heat into work is impossible. As you remember, complete conversion of heat into work is impossible without having some effect elsewhere. Just like in the beginning I told you, suppose you want to send some money from one place to the other place, then some commission you have to pay to the post office. Correct? Some money, 1%, 2%, whatever be. Same situation is there. If you want to convert heat into work, then complete heat can't be converted to work, because system will use some energy. Only then it will convert to work. Heat will be converted to work. Only a system will absorb that some energy. That's why fully you can't convert. It is impossible. Then this is the actually I have told you about the distance. 2 point I told you. Third point, in the term of entropy. The entropy of the universe is continuously increasing. You remember, entropy means disturbance in the universe is going on. It is not you can say fixed. Always it is changing continuously. It means entropy is changing. And this is the you can say second important point of the second law. In terms of energy, the energy of the entropy of the universe is increasing maximum. Entropy of the universe is continuously increasing, or it is increasing maximum. Okay. Total energy is constant, but entropy is increasing continuously. This is the actually I discussed second law. What is the third law? Then third law I am telling you. Third law of thermodynamics states that the entropy of all crystalline solids may be taken as zero at the absolute zero. Condition is there. Means for crystalline solid, pure crystalline solid, it will apply for pure crystalline solid. That is the third law states that the entropy of all crystalline solids may be taken as zero. At the absolute zero. At the absolute zero of temperature. It is used in this concept is used in the calculation of absolute entropy of any substance in any state at any temperature. Okay. What is limitation? The limitation of this law is that many solids do not have zero entropy even at absolute zero. This is the limitation. This question is asked. All you can say this is limitation. Many solids do not have you can say absolute you can say zero entropy. Many solids do not have zero entropy even at absolute zero. What are the example? Then that is the glassy solids and solids containing you can say a distance mixture of isotopes and like chlorine gas, isotopes of chlorine gas, or crystal of certain you can say combination. Just for example, H2O, CO, NO, N2O. Okay. Then these I told you H2O, CO, N2O, NO. These substances they don't have absolute zero even at absolute zero. Entropy, their entropy is not zero at absolute zero. This is the exception. Again you remember example I told you H2O, CO, N2O and NO. And one more law is there, thermodynamics, that is the zeroth law of thermodynamics. Zeroth law. What is this law? Zeroth law. Then what it states that two you can say substance or two solids have suppose it is joined, two solids are joined to each other, correct, and the temperature is suppose same temperature, and these two are again joined with the third, then now you will find all three have same temperature, or even suppose it is a fluid A and B, both are joined to each other and their temperature is suppose same. Then now if suppose these two are joined with third substance, then now all will have same temperature. This is actually called zeroth law of thermodynamics. Okay. Then today I am stopping only here. Main points of this I discussed. Now I have to discuss many additional, you can say, information I want to give. That I will discuss in the next class. Okay, thank you.